Through a microscope. Focus question. How do microscopes help people learn about the world? Barely visible. A human hair is one of the smallest things the human eye can see. Imagine though, if you could shrink yourself until that hair looked as thick as your arm. Imagine if the hair looked as flat as a tree trunk. What would you see? The hairs on a fly's legs would look like enormous spikes. The fly would look like a monster with gigantic eyes. That's the close-up view with a microscope provides, and it changes how we see the world. The first simple microscopes. For thousands of years, people have been interested in taking a closer look at their world. The ancient Greeks used glass globes filled with water to make objects appear larger. In the 1st century CE, the Romans discovered that glass that was thick in the middle and thin on the edges made things appear larger. This was the first magnifying glass. People started to figure out how to make better glass lenses in Europe in the 1600s. With that discovery, the microscope was invented. At first, the microscope was just a sort of fancy magnifying glass. It had a single lens mounted above a holder for the object being viewed. Most magnifying glasses only make objects appear about 5 to 10 times larger in size. That was the magnifying power of the first simple microscopes. Compound microscopes. Early microscope users figured out that they could put two magnifying glasses in line with each other. The second lens magnified the image from the first lenses, creating greater magnification. With the combination of two lenses in a single microscope, the compound microscope was born. Today, compound microscopes can magnify objects up to 1,500 times their original size. Magnified 20 to 30 times. One of the first early microscope users was Robert Hooke. Hooke improved the early compound microscope, which could only magnify objects about 20 to 30 times their actual size. He was also one of the first people to take detailed notes on what he saw through a microscope. Hooke published his observation in a book in 1665. Hooke's book had drawings of close-up views of a louse and a flea. He drew the compounded eyes of a fly in greater detail than anyone had ever seen before. Hooke also sketched sections of plants and seeds. When he examined a thin selection of cork under a microscope, he discovered that it was made up of tiny chambers. He described those tiny chambers as cells. Over time, the term cell became used to describe the tiny building blocks of all living things. Today, examining thin slices of plants lets us see how seeds are formed. It reveals how cells make up plant leaves. It shows the cell that allow water and nutrients to move in plant stems. Magnified 20 to 200 times. Historians believed that Hooke's book inspired any other early microscope user, Antony van Leeuwenhoek. Van Leeuwenhoek was a cloth merchant, not a scientist. However, he used magnifying glasses to examine the different types of fabric he bought and sold. When he saw Hooke's drawings of the microscope world, Van Leeuwenhoek started making lenses of his own. He soon discovered a way to create better lenses. As a result, he was able to make microscopes that magnified objects more than 200 times. Using these stronger microscopes, Van Leeuwenhoek discovered the red blood cells. He also discovered tiny life forms called microorganisms living in lake water and in the scraping from someone's teeth. Microorganisms are living things too small to see with the naked eye. Before Van Leeuwenhoek's time, no one even knew they existed. Microscopes revealed that microorganisms live everywhere. Today, if you use a microscope in the classroom, it probably magnifies objects about the same amount as Van Leeuwenhoek's early microscopes. Although 200 times magnification might not seem like a lot, it's enough to reveal details invisible to the naked eye. Even something as simple as sand is seen in a new light under a microscope. Without magnification, sand looks ordinary and plain. Under magnification, it's clear that sand from the ocean's edge contains microscopic shells, coral, and volcanic rock. Magnified 200 to 1500 times. Because the lenses in early compound microscopes weren't perfect, they often created changes in the image. It was hard to tell what was real and what was just an effect caused by the way light passed through the lens. In the early 1800s, a scientist named Joseph Jackson Lister invented a new type of lens. This lens made microscopes more powerful and reliable. As a result, microscopes allowed new discoveries in science and medicine. In the mid-1800s, Louis Pasteur discovered that microorganisms in the air could cause milk to spoil. Around the same time, the improved microscope allowed doctors to see microorganisms in the bodies of sick people. This discovery caused huge changes in the practice of medicine. The early compound microscope also led to the discovery that no two snowflakes are alike. Wilson Bentley was known as Snowflake Bentley for his work with snowflakes. He paired a camera with his microscope in the late 1800s and early 1900s to take photographs of more than 5,000 snowflakes. He showed that snowflakes are mirror images of themselves in 6 different directions. Compound microscopes also allowed scientists to discover that salt, sugar, and some other things in nature form crystal structures. Salt is made up of only 2 types of regularly spaced particles. As a result, it forms crystals shaped like little cubes. Table sugar is made up of 2 different, simpler types of sugar. It forms crystals that are slanted at each end and longer than salt crystals. Seeing the world's tiny details can help people understand how things work. For example, a man named George de Mestral became curious about the cockleburs that stuck to his clothing and his dog's fur. He took a closer look at the burrs under a microscope. He saw that they had tiny hooks that latched onto loops in the fabric of his pants. De Mestral worked to recreate the design using fabric. Years later, the result was Velcro. Velcro is made up of 2 pieces of fabric, one covered in thousands of tiny hooks and the other covered in thousands of tiny loops. The hooks and loops let the 2 pieces of fabric zip together. Magnified 1,000,000 times. Because of the way light works, there is a limit to how much a compound microscope can magnify things. During the past century, scientists developed microscopes that use different ways to create images. One such microscope uses energy called electrons. Electron microscopes provided the greatest magnification in any existing type of microscope, magnifying samples up to 1,000,000 times. Conclusion. With each new power of magnification, more detail is relieved about the smallest structures of plants, animals, and materials. As a result, microscopes have allowed countless discoveries in nearly every field of science. Microscopes make the invisible visible, allowing us to explore the world in an entirely new way. Stains and dyes. Many cells and other small objects are transparent or see-through. This makes them difficult to see under a microscope. Stains and dyes have been used since the 1800s to make objects stand out more against their backgrounds. This makes the object easier to see with a microscope.